Hello, this is Mr. Allen, and I am your son or daughter's math teacher, and I wanted to give you an update for the week of April 12th. This week in geometry, we're looking at inscribed angles. So here we're asked to find to determine the value of x. And so based on the image here, the picture, we know that the inscribed angle is 1/2 the measure of the intercepted arc. And we know that those inscribed angles in this case, since they're hitting the same arc, so we're talking about this angle here and that angle there, the start angles, and they both are intercepting the same arc. They therefore have to be congruent. So we're just going to set the 3x plus 7 equal to 6x minus 11. We're going to minus 6x from the right side and minus 7 from the right or the left side, and then divide both sides by -3, and we'll get that x is equal to 6. In Calculus AB, we are looking at areas and volumes. And so we are asked to consider the region bounded by the curves y, or f of x equals the square root of x, and g of x equals x squared. And we're going to find the volume of that region if it's rotated around the line x equals -2. So this is the graph of our square root of x and our x squared. We see that there is a bounded region between 0 and 1. It's that shaded region. We're going to rotate it around that blue vertical line that I added there. This is going to involve something called the washer method, and we are doing this rotation. This is a horizontal rotation. So in this case, I need to use the formula pi from c to d integral of big R squared minus little r squared dy. Everything's going to be in terms of y. So I need to convert everything into terms of y, and it turns out that our big radius here, big R, is going to be the square root of y plus 2, and little r is going to be y squared plus 2. So now we're just going to plug all this information into our formula, and with the magic of integration, we will get an answer of approximately 5.131. In Calc BC, we are going to be looking at polar coordinates today. So this particular problem says calculate the area enclosed by the inner loop of the graph of r equals 1 plus 2 sine theta. So here's a graph of that function, and I have shaded in that inner loop, and we're trying to find the area of that inner loop. It turns out that the inner loop is when theta is between 7 pi over 6 and 11 pi over 6. So we are going to need to find the area by integrating 1/2 the integral from 7 pi over 6 to 11 pi over 6 times the quantity, or I guess it's not times the quantity. The integrand is 1 plus 2 sine theta quantity squared d theta. And this would be the exact answer. And the approximate answer, or the area, would be 0.544 to 3 decimal places. Some final thoughts. Please make sure that you are checking your son or daughter's grades online. That's really helpful, just to help make sure they're not missing things or checking their progress. Also, is this summer break? It is not summer break yet. Please help encourage your son or daughter that summer break is not till the end of May, or the beginning of June might be a better way of putting it, and tell them that it's not time to let off the gas. It's time to put their foot on the gas and keep working hard to finish strong this year. Finally, please be aware that I'm available for help during the advisory periods. There's an advisory period on Thursday, and there's one on Friday. I do not have a lot of students requesting help during those periods. That would be a perfect time for your son or daughter to get some extra help. One final thing is, I would like to say it's been really nice having more students back in the class. And I think maybe they've enjoyed being back in the class too. So anyways, have a great day. Thanks for your attention.